Hello Year 12. This is the first video in our new topic, which is carboxylic acids and esters. We're going to be looking at the properties and reactions of carboxylic acids today. So these are the specification points we'll be covering. We're going to explain the water solubility of carboxylic acids by looking at the bonding. I'm going to look at the reactions of carboxylic acids. So the carboxylic acid group is often called the carboxyl group because the carboxyl group applies to whether the proton is on or if it's been taken away. It's essentially the fully oxidized form of a primary alcohol or an aldehyde. And the chemistry is dominated by the fact we've got these two very electron withdrawing oxygens here. How do we name carboxylic acids? Well, the carboxylic acid group always takes the first position and it adds an anoic acid bit to the name. So here we have ethanoic acid. On this one you can see that the methyl group is in the second position, the carboxylic acid group in the first, so this is 2-methyl propanoic acid. And here the bromo group is in the third position, with this being the first, so it's 3-bromo-butanoic acid. As I mentioned earlier, the carboxyl group is very polar. We have these two oxygens that are pulling away the electrons from the carbon, and they actually, despite being drawn like this, can share this partial negative charge between the two of them. Another implication of this is that electrons are withdrawn from the hydrogen atom here, making it very, very easy to deprotonate. The charge, when you do deprotonate it, is shared between these two oxygens, so that in actual fact it's very easy to take a proton off, making them quite acidic. Generally we think of carboxylic acids as weak acids, and their pHs are usually in the region of 4 to 5. The polarity of our carboxylic acids, coupled with the fact that we've got two oxygens, each with two lone pairs, mean that we can form a lot of hydrogen bonds. In addition, we've also got this electron-deficient hydrogen. So we can make a lot of hydrogen bonds with water, which adds to the incredible solubility of carboxylic acids. However, not all carboxylic acids are that soluble, and that's because only the carboxyl group is actually polar. The rest of the molecule, if there's a long hydrocarbon chain like this molecule, is non-polar. So we get a situation where only the top end of the molecule can actually be solvated in water, but the rest of it cannot. So the longer the hydrocarbon chain, generally, the less soluble our carboxylic acid is. Carboxylic acids have very high boiling points, and that's because when they're in liquids, the liquid state, they can form two hydrogen bonds to make a dimer. A dimer, if you think of it as being two monomers, they join up to make one big molecule, and it's very hard to break these two bonds apart. Finally, we need to look at the reactions of carboxylic acids, and they react pretty much exactly like acids. With metals, they make salt and they make hydrogen. With bases, they make water and a salt. And with carbonates, they make carbon dioxide, water, and a salt. Notice that be very careful about the charge on your carboxylic acid being only 1- when we're bonding it with metal ions that have more than one positive. So, for example, magnesium is dipositive, so I've had to put a 2 down here. The reaction with carbonates we use as a chemical test because it's quite clear to see. There's a lot of effervescence that we can watch, and it's a reaction that won't happen with alcohols, whereas the reaction with sodium hydroxide sometimes will happen with alcohols. Okay, thank you very much for watching. Make sure you do your prep work for